been waiting way too long. Yeah, I've been down here trying to get it. Yeah, I've been waiting way too long.
This video is for Chapter 6, Part 2, which we're going to discuss the reasons for similarity in triangles and a few other applications. So angle-angle similarity says if two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. So for instance, if this is 42 degrees and this is 42 degrees, and then this is 47 degrees and this is 47 degrees, then those triangles are going to be similar. Now, if you think about it, remember back, if those two angles are congruent to D and E, then isn't C congruent to F? Yes, C has to be congruent to F because all three of those numbers have to add up to 180. So if you have two congruent angles in both triangles, then you can say that the triangles are similar and you can solve problems that way. The next is side-side-side similarity, which says if all the sides of one triangle are proportional to all the sides of another triangle, then the triangles are similar. So proportional, remember, means it has to have a constant ratio. So I'm going to give some values here, and then we're going to see how they are proportional. All right, so if these are the values, we're going to check the ratios. So 9 over 3 has to be equal to 12 over 4, which has to be equal to 15 over 5. And when I simplify all of those, it equals 3. And so the ratios are constant, therefore all the sides are proportional, and therefore those triangles are similar. The last one is side angle side similarity. If two sides of one triangle are proportional to two sides of another triangle, and the included angles are congruent, then the triangles are similar. So let's start with congruent angles. Let's say A is congruent to D. Then what needs to happen is AB needs to be proportional to DE, just as AC needs to be proportional to DF. If those ratios are not constant, then this is not similar. And I underline proportional because I don't want you to be confused with congruency. We're not talking about congruency, we're talking about similarity. So just kind of go an easy example here. If this is 14 and this is 7, then this is 12 and this is 6, right? 14 over 7 is 2, 12 over 6 is 2. So those are proportional. And the included angle, remember included angles, the angle that is formed by those two sides is congruent. It would not matter if C is congruent to F based on the sides that are given. That's not going to matter for side angle side similarity. All right, if we know the scale factor of a triangle or two triangles, we can draw the second figure. So here ABC is similar to XYZ by a scale factor of 2 to 3. Notice that the 2 goes with the triangle ABC, so then I wrote it as a ratio here. So what we need to do is we need to draw triangle XYZ. Well, before we can draw XYZ, we need to figure out what the side lengths are going to be. So I'm going to write a proportion here. So AB is 4. AB corresponds to XY. So AB is up here at 4, and then this is XY. Equals 2 over 3 because that's my scale factor. So I'm going to solve that, and that is 2 times xy equals 12, and so xy equals 6. So that's one of my values. Now I can tell that my original triangle is a right triangle, so my new triangle is going to be a right triangle because remember the angles are congruent. And also, which triangle is bigger, ABC or XYZ? ABC is bigger because the bigger number goes with the XYZ. So I'm going to go ahead and draw a bigger right triangle. So now I need to find YZ, which means I'm going to use BC. BC is 5, and then I'm comparing that to YZ, it's 2 over 3. And so 15, 5 times 3 is 15 divided by 2. YZ is going to be 7.5. And then lastly, 3 over XZ equals 2/3. 3 times 3 is 9, divided by 2 is 4.5. So XZ is 4.5. Okay, so I just solved those proportions in my head, but remember this is how you set up the proportion to solve. So we just drew the figure based on the scale factor. All right, the next question asks us to find the perimeter of XYZ and ABC. All right, so the perimeter, let's start with ABC, is 5 plus 4 is 9 plus 3 is 12. And triangle XYZ's perimeter is 18. So what I want to figure out here is, does the ratio of the perimeter stay the same as the ratio of the side lengths like it was here, 2 to 3? So remember, we're going to write it as triangle ABC over triangle XYZ. So that's 12 over 18. And if I divide both of those by 6, I do indeed get 2 over 3. So the ratio of the perimeters will be the same as the ratio of the side lengths in similar figures. All right, so now we're going to talk about area. So here are my original figures. To find the area of a right triangle, it's very simple. It's just base times height divided by 2. And that's only if I know the height. And remember, the height is the altitude, which has to be at a right angle. So it kind of made it easy on us here. So what are the area of these? So the area of ABC is going to be 3 times 4 divided by 2. 3 times 4 is 12 divided by 2 is 6. So the area of triangle ABC is 6 units squared. And then the area of XYZ is going to be 4.5 times 6 divided by 2, which if you think about it is the same as 4.5 times 3, right? You just divide the 6 by 2 and I would get my answer. So that's 13.5 units squared. So now I want to compare these ratios and see what I find. So 6 over 13.5. Now 13.5 is not going to be divisible by anything really pretty here. So what I'm going to do instead is I'm just going to divide this and get the decimal format. And the decimal format that I get is 0.44. And if you remember, our original scale factor was 2/3. And 2/3 is 0.666. And so what happens here is that the ratio of the area is going to be the ratio of the side lengths to the second power. So if I do 0.666 times 0.66666, I get 0.44. And I know that may be hard to see, but 0.4 repeated is the same as 4/9. And if I square 2/3, 2/3 squared, I square both top and bottom is 4/9. Okay, so again, the ratio of the areas will be the ratio of the side lengths to the second power. So for example, just another example to look at, if the original scale factor is 3/5, then the ratio of the areas is going to be 3/5 to the second power, which would be 9/25. So if I have similar figures whose scale factor is 3/5, then if I know the areas, or if I know one area, I can find the second by using this ratio that is the original scale factor raised to the second power.
I've been waiting way too long. Yeah.